transformers are available to provide 380 volts alternating current 3-phase power at 50 Hz. These transformers can either step up voltage from a low voltage, such as 240 volts, or step down voltage from a higher voltage, such as 480 volts. A step-up transformer designed to convert 240 volts alternating current 3-phase at 50 Hz to 380 volts alternating current 3-phase at 50 Hz is one option. The input requirements would be 240 volts alternating current 3-phase at 50 Hz, and the output would be 380 volts alternating current 3-phase at 50 Hz. The power rating for this transformer should be at least 5 kilowatts to accommodate the machine's power requirements. Alternatively, a step-down transformer can be used to convert 480 volts alternating current 3-phase at 50 Hz to 380 volts alternating current 3-phase at 50 Hz. This transformer would have an input of 480 volts alternating current 3-phase at 50 Hz and an output of 380 volts alternating current 3-phase at 50 Hz. Like the step-up transformer, the power rating should be a minimum of 5 kilowatts. Transformers meeting these specifications are generally available from various manufacturers and can be sourced through electrical equipment suppliers or online retailers. When selecting a transformer, there are several important factors to consider. Firstly, ensure that the transformer has an appropriate power rating capable of handling the 5 kilowatt machine's load. Secondly, verify that the transformer is specifically rated for a frequency of 50 Hz to match the machine's requirements. Thirdly, consider the transformer's efficiency and power factor to minimize energy losses during operation. High-efficiency transformers will reduce wasted energy and lower operating costs. The power factor is a measure of how effectively the transformer uses electricity. A power factor close to 1 indicates high efficiency. Fourthly, always adhere strictly to all safety requirements during the installation and operation of the transformer. This includes proper grounding, overcurrent protection, and adherence to local electrical codes. Improper installation or operation can result in electrical shock, fire hazards, or damage to equipment. A 3-phase transformer consists of 3 individual transformers connected in a specific configuration. The 2 most common configurations are delta and Y. In a delta configuration, the 3 windings are connected in a closed loop forming a triangle. In a Y configuration, one end of each winding is connected to a common neutral point, forming a star shape. The choice between delta and Y depends on the specific application and the desired voltage and current characteristics. When selecting a transformer, it is important to consider the impedance. Impedance is the total opposition to current flow in an alternating current circuit, including resistance and reactance. The transformer's impedance affects the voltage regulation and short-circuit current. Lower impedance transformers provide better voltage regulation but higher short-circuit current. Higher impedance transformers provide poorer voltage regulation but lower short-circuit current. Voltage regulation is the change in output voltage from no load to full load. Good voltage regulation is important for maintaining a stable voltage supply to the load. Short-circuit current is the current that flows during a short circuit. High short-circuit currents can damage equipment. Transformers are typically cooled by either air or oil. Air-cooled transformers rely on natural convection or forced air to dissipate heat. Oil-cooled transformers use oil as a coolant, which circulates through the transformer and dissipates heat through a radiator. Oil-cooled transformers are generally more efficient and can handle higher power ratings than air-cooled transformers. The choice between air-cooled and oil-cooled depends on the specific application and the ambient temperature. The location where the transformer will be installed should be considered. Ensure adequate ventilation and protection from the elements. The transformer should be installed in a dry, well-ventilated area away from flammable materials. Protective devices, such as fuses or circuit breakers, should be installed to protect the transformer from overloads and short circuits. Regular maintenance should be performed on the transformer to ensure its continued safe and reliable operation. This includes inspecting the transformer for signs of damage, cleaning the transformer, and testing the insulation resistance. The insulation resistance is a measure of the integrity of the transformer's insulation. Low insulation resistance can indicate insulation breakdown and a potential for failure. Before installing a transformer, it is important to consult with a qualified electrician to ensure that the installation meets all applicable electrical codes and safety regulations. A qualified electrician can also help select the appropriate transformer for the specific application and provide guidance on proper installation and maintenance procedures. When dealing with electrical equipment, always prioritize safety. Work should only be performed by qualified personnel. Ensure that all power is disconnected before working on any electrical equipment. Use appropriate personal protective equipment, such as safety glasses and gloves. Follow all safety procedures and guidelines. If unsure about something, consult with a qualified electrician. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe installation of electrical equipment. Familiarity with the NEC is essential for anyone working with electrical equipment. The NEC covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. The specific requirements for transformer installations can be found in Article 450 of the NEC. This article covers topics such as transformer location, ventilation, protection, and grounding. In addition to the NEC, local electrical codes may also apply. It is important to consult with the local electrical inspector to ensure that the installation meets all applicable requirements. Understanding transformer nameplate data is crucial for proper selection and operation. The nameplate provides key information about the transformer's characteristics, including voltage ratings, power rating, frequency, impedance, and insulation class. The voltage ratings indicate the primary and secondary voltages for which the transformer is designed. The power rating indicates the maximum apparent power that the transformer can deliver without exceeding its temperature limits. The frequency indicates the frequency for which the transformer is designed. The impedance indicates the transformer's impedance, which affects voltage regulation and short-circuit current. The insulation class indicates the maximum operating temperature of the transformer's insulation. When selecting a transformer, it is important to choose one with voltage ratings that match the available supply voltage and the required load voltage. A transformer's power rating should be greater than or equal to the load's power requirements. The transformer's frequency should match the supply frequency. The transformer's impedance should be selected based on the desired voltage regulation and short-circuit current. The transformer's insulation class should be appropriate for the ambient temperature. Transformers are essential components in many electrical systems. Understanding their characteristics and proper installation and operation is crucial for ensuring a safe and reliable power supply. By carefully considering the factors discussed, one can select and install a transformer that meets their specific needs. Remember to prioritize safety and consult with qualified personnel when working with electrical equipment. It's also important to know the basics of three-phase power. Three-phase power is a type of alternating current electrical power that uses three wires to deliver power. Each wire carries an alternating current that is offset by 120 electrical degrees. Three-phase power is more efficient than single-phase power and is commonly used in industrial and commercial applications. There are two main types of three-phase connections, delta and Y. In a delta connection, the three phases are connected in a closed loop, forming a triangle. In a Y connection, the three phases are connected to a common neutral point, forming a star shape. The voltage between any two phases in a delta connection is the line-to-line voltage. The voltage between any phase and the neutral point in a Y connection is the line-to-neutral voltage. The line-to-line voltage is always greater than the line-to-neutral voltage. In a Y connection, the line-to-line voltage is equal to the line-to-neutral voltage multiplied by the square root of 3, or approximately 1.732. Three-phase power can be used to power a variety of loads, including motors, lighting, and heating equipment. Three-phase motors are more efficient and powerful than single-phase motors. Three-phase lighting systems provide more even illumination than single-phase lighting systems. Three-phase heating systems provide more efficient heating than single-phase heating systems. When working with three-phase power, it is important to understand the different types of connections and voltage levels. It is also important to use proper safety precautions. Always disconnect power before working on any electrical equipment. Use appropriate personal protective equipment. Follow all safety procedures and guidelines. Consult with a qualified electrician if you are unsure about something. Regarding the 5 kW 380 volts alternating current 3-phase 50 Hz machine intended for trade show demonstrations, it is crucial to verify that the selected transformer is compatible with the power source available at the trade show venue. Trade shows often have specific electrical requirements and limitations. Contacting the trade show organizers or venue management to obtain information about the available power supply, including voltage, phase, frequency, and current capacity, is essential. This information will help determine the appropriate transformer configuration and ensure that the machine can be safely and effectively demonstrated. If the trade show venue provides 240 volts alternating current 3-phase power, then a step-up transformer will be needed to convert the voltage to 380 volts alternating current 3-phase. If the venue provides 480 volts alternating current 3-phase power, then a step-down transformer will be needed. In either case, the transformer must be rated for at least 5 kilowatts and 50 Hz. It is also important to consider the transformer's physical size and weight, as it will need to be transported and set up at the trade show. Compact and lightweight transformers are generally preferred for trade show applications. Additionally, ensure that the transformer is properly grounded and protected from overcurrent. Overcurrent protection can be provided by fuses or circuit breakers. Proper grounding is essential for safety and to prevent electrical shock. The transformer should be inspected before each use to ensure that it is in good working condition. Look for any signs of damage, such as cracked insulation or loose connections. If any damage is found, the transformer should be repaired or replaced before use. When operating the transformer, monitor the voltage and current to ensure that it is operating within its rated limits. Overloading the transformer can cause it to overheat and fail. If the transformer starts to overheat, disconnect the load and allow it to cool down. With careful planning and preparation, the 5 kW 380 volts alternating current 3-phase 50 Hz machine can be successfully demonstrated at the trade show. By selecting the appropriate transformer and following proper safety procedures, a machine can be operated safely and reliably.